Okay, we're going to look at problems that I call labeling problems. So what makes a problem a labeling problem? A labeling problem is a problem that uses a variable and other things based on that same variable to be able to come to conclusions in your problem, okay? So, the first problem we're going to look at is a problem that requires 1 ounce of rye flour to 3 ounces of wheat flour, and we want to build a 50-ounce loaf of bread. Okay? So how many ounces of rye flour do we need, and how many ounces of wheat flour do we need to get to a 50-ounce loaf of bread? Now our X is going to represent the number of times we use 1 to 3, your 1 ounce to your 3 ounce, okay? I'll write the word 2 here to make it more obvious. So, my equation becomes 1 times x plus 3 times x is equal to 50. Continue solving your equation. 1x plus 3x is 4x. Divide by 4. And x is going to equal 2.5. So we have 12.5 ounces. Well, rye has 1 times x, right? So therefore, if I put my 12.5, my rye is equal to 1 times my x. So therefore, this is 1 times 12.5 ounces, which equals 12.5 ounces of rye flour. So you see how you use your variables to produce what you need to know. My wheat flour was 3 times x, which is equal to 3 times 12.5 ounces, which gives you 37.5 ounces. So, 12.5 ounces plus 37.5 ounces is going to equal your 50-ounce loaf of bread. So you see how we used our variable to represent the number of times that we're going to take that recipe. Okay, now let's look at another labeling problem. When you're doing labeling problems, it's really important to decide what is the foundation of the variable. What does the variable belong to? Okay? So, it says here, a travel agent needs to book 83 tickets. So we have a total of 83 tickets must be booked. And then it says he books 6 more tickets on airline A than on airline B, and on airline C he booked 5 more than twice as many as airline B. Okay, we have airline A, airline B, and what we have to do is express the number of tickets for each one of these airlines in airline C. And listen to what it says about it. It says that airline A booked 6 more tickets than airline B. That means airline A depends upon the number for airline B. And then it says for airline C, he booked 5 more than twice as many as airline B. So both A and C rely on B. Therefore, B is going to be your variable. And then it said, remember, airline A has 6 more than airline B. So it would be airline B plus 6 or X plus 6. And airline C says that that has 5 more than twice as many as airline B. So 5 more than, so that's 5 plus twice as many as airline B, which is 2 times X. Okay? Now that we have an expression for each amount of tickets bought for each airline, it's the number, and the number of tickets on each airline. What is our equation? Well, our equation is the number of tickets of A plus the number of tickets for B plus the number of tickets for C is equal to my total number of tickets, which is 83. Okay? So now let's change our expressions for this. Number of A is X plus 6. The number of B is X. And the number of C is 5 plus 2X equal to 83. Combine your like terms. X plus X is 2X, and 2X plus 2X is 4X. 6 plus 5 is 11, is equal to 83. Solve your equation. Leaves you 4X is equal to 83 minus 11, which would be 72. Divide by 4. Now remember, we're talking about number of tickets. So if we end up with a decimal, we have a mistake somewhere, because you can't have part of a ticket. You have to have whole tickets. 72 divided by 4 is 18. Goes in ones, carry my 3, and 4 into 32 is 8. So we have 18 tickets. So for airline B, which is equal to X, this one is 18 tickets. And for airline A, it is 18 plus 6, which is 24 tickets. And for airline C, 2 times 18 is 36, and 36 plus 5 is 41 tickets. Now if we add these all up, that's 12, 13, carry my 1, 2, 4, 8. So we came out with the same. So we checked our answer by adding up all the tickets that were booked. Okay? Do you see that? How that works? So you pick and you choose what is the one to make it be the base, and all the others compare to that. So now let's look at another problem. The next one says we have the sum of 3 consecutive odd numbers. And that sum is equal to 87. What are the 3 integers that add up to 87? Well, first of all, let's look at odd numbers. Remember, odd numbers are like 1, 2, 3, 5, 9, 11, anything that ends in 1, 3, 5, 9, and 11. So if we just took 3 odd numbers, how about 23, 25, and 27? If you compare these numbers, you will notice if I choose my base as 23, 25 is 2 more than 23, and 27 is 4 more than 23. So the same relationship exists between all consecutive odd numbers. Or if I choose my middle one, my 23 is 2 less than that one, and my 27 is 2 more than that one. So there's several different ways you can assign this. And I think I'm going to work it both ways, okay? So your first one is integer number 1 is going to be my x. Integer number 2 is my x plus 2. And integer number 3 is equal to x plus 4. Now remember, the sum of these is equal to 87. So that means number 1 plus number 2 plus integer number 3 is equal to 87. So this is x plus 2 plus x plus 4 is equal to 87. Add our like terms, x plus x plus x is 3x. 2 plus 4 is 6. And now solve your equation. Eliminate that addition or subtraction by subtracting 6. That makes 0. And I have 3x is equal to 81 divided by 3. And x is equal to 27. So integer number 1 is equal to 27. Integer number 2 is 31. And integer number 3 is 33. No, 29. And then 31. Okay? Get the numbers right here. I added too much. 27 plus 2 is 29. 29 plus 2 is 31. So you can see these are easily solved in this fashion. What if we did the other way and had number 1, number 2, and number 3? This made number 2 is equal to x. Number 1 is x minus 2 because it's 2 less. And number 3 is x plus 2. So now what happens when you do it? Well, x minus 2 plus x plus 2 is equal to 87. X plus x is 3x. Negative 2 plus 2 is 0, so that gives you 3x plus 0, which is 3x, is equal to 87 divided by 3, and x is equal to 29. Okay? So come up here, number 2 is where my x is, so that's 29. Subtract 2 is 27. Add 2 to 29 is 31. So you see, you get the same answer no matter which way you work this problem. It works out very nicely when we do that. Okay, and you will find other problems like this where you base things on one of the pieces and then you make expressions for the others using what you labeled for your x. So these are the labeling problem type things you're going to be doing in this unit.